Before continuing our introduction of truth tables, we've got those 5 basic truth tables out of the way. Before continuing that, we're going to go back and we're going to review what a compound statement looks like in symbolic form and what type of compound statement, how we can tell what type of compound statement it is. So for the first one, we're going to do the first couple together, and then I'm going to give you some time to work on it on your own. I want you to pause the video and see how you do. Number 1 says that apples are a good source of fiber and oranges are a good source of vitamin C. Well, I have 2 statements there. I have a statement about apples, I have a statement about oranges, and I have a joining word and. So going in alphabetical order, my first statement is P, then I have and as my joining word, Q. This is a conjunction because it's named by that joining word. Rather than do number 2, we're going to do a more complex one. Let's go down and do number 7. So number 7 says, we will advance in the tournament if and only if Max plays or Pondo does not show up. Now notice my comma. My comma signifies that I have parentheses. And outside the parentheses, at the end, I have this or Pondo does not show up. So how many statements do I have in all? Well, I have we will advance in the tournament. That's one statement. We have Max plays. That's a second statement. And we have Pondo does not show up. So we have 3 statements, P, Q, and R. Inside the parentheses, I have this first part of my sentence going on. Then I have or, there's that conjunction, Pondo does not show up. Remember, any not statement is going to be negated. This is my third statement, so that would be PQR. So this would be not R. Inside my parentheses, I have an if and only if. If and only if is that biconditional with a 2-ended arrow. So we will advance in the tournament would be P. If and only if Max plays is Q. That's inside parentheses because there's my comma. Or Pondo does not show up, not R. I need to figure out what type of compound this is. It's labeled by type. It's the major symbol that goes on outside the parentheses. So that's going to be an or a disjunction. We're going to call it a disjunction. Number 1 was a conjunction. Number 7 is a disjunction. So pause the video, determine what all of these are, and then we will start again. All right, here you go. All of them are complete. We are going to talk through them fairly quickly. So take a second, check and see which ones you got right, which ones you got wrong. The first 4 are fairly simple. Then we get to some more complex compounds. Number 2 says, I've worked all week, but I have not been paid. That but is the same, is a conjunction just like and or but, both mean conjunction. Not been paid, so that's not Q. P and not Q conjunction because of that keyword but. Number 3, it is false that. Anytime I see it is false that or it is not the case that, I know I have a negation. So inside parentheses, it is false that sets up my inside parentheses. Mr. Farinelli is the president or Miss Chow is the treasurer. The only time I label a compound as a negation is when that negation is the only thing that takes place outside the parentheses. Number 4, I am hungry, comma. So I am setting off a grouping after that. I'm hungry, comma, and this is a conjunction. I want to eat a healthy lunch and I want to eat in a hurry. So these go in parentheses because of where the comma is placed. It's a conjunction because of the and that is outside the grouping symbols. Number 5, Mike made pizza and Dennis made a chef salad, comma. So I know to group those together, but that's a conjunction. Gil burned the lemon squares. So that but symbolizes a conjunction. That's what's going on outside the parentheses. Number 6, if today is Monday, then. So we've got an if-then statement. Our comma's here, so I know I'm going to group together what comes after. So P, if then, and then I've got my in parentheses Q and R. Library is open and we study together. It's labeled a conditional because that's what is going on outside of the parentheses. We already did 7 together. Number 8, the election was fair if and only if. If and only if symbolizes that biconditional. If and only if the polling stayed open until 8 p.m., comma. That tells me all that gets grouped together because of the placement of the comma. Or, the or is on the outside, so it's a disjunction. We will request a recount. Number 9, if the dam holds, then we can go fishing, comma. All of that if-then statement is before the comma, so it's in parentheses. If and only if, there's that biconditional, the pole is not broken, not are. So the biconditional is going on outside of the parentheses. That's why I label that as the type of compound for that one. Number 10, the copier is out of toner, comma, so my grouping is going to start then. Or, so the or is outside the parentheses, and then grouped together, the lens is dirty or the corona wires are broken. This is a disjunction because of that or that's going on outside the parentheses. Number 11, if it is not too cold, then we can take a walk, comma, or we can go to the gym. Because of the placement of the comma, I have my if-then statement in parentheses, and my compound is a disjunction. And finally, it is false that. Remember, it is false that symbolizes that, that I have a negation. It could have also said it is not the case that. Jasper is a tutor and Mark is a secretary. That goes in parentheses. It's being negated. And so that one is, that's all that's going on outside the parentheses. So that statement is a negation. Okay, let's move on into our truth tables now that we've reviewed our compound statements. A conjunction, remember, for a conjunction to be true, both statements must be true. Both statements must be true for the conjunction to be true. For the disjunction, that's my or. And remember, my or is an inclusive or. So at least one statement. At least one statement. One statement, the other, or both must be true for the disjunction to be true. Okay, we have 2 columns of math problems. 2 columns, 4 rows in each column. So we have 8 different situations where I have math problems. If you look down the first column, what type of compound is each of these in the first column? Well, each of these in the first column is a conjunction. What about my second column? Well, each of these is a disjunction. It says to determine if each compound statement is true. Well, for let's look at the first row. 5 plus 2 is 7, that's true. 1 plus 1 is 2, that's true. If both of them are true, if it's a conjunction and both of them are true, then the whole statement, the compound statement, is true. Let's move on down these conjunction statements. Well, we already said 5 plus 2 is 7, that is true. What about 1 plus 1 is 3? No, 1 plus 1 is not 3, so that one's false. If I've got true and false, well, it's a conjunction. They're not both true, so that conjunction is false. What about the next one? 5 plus 2 is 8. That's not true. That's false. 1 plus 1 is not 3. So if they're both false, then for sure that conjunction is false. And then I've got 5 plus 2 is 8. That one's false. That one's true. Well, again, if I have one false statement, my conjunction has to be false. Now let's look at our disjunction column and see how they compare. If you look at the statements are exactly the same. I've got 7, that's true. 2, that's true. Disjunction, true or true. Yep, that's true. This one, 7 is true. That one is false, though. What about this? True or false? Well, that disjunction says that if at least one statement is true, then the disjunction is true. That's different than a conjunction. For a conjunction, my and means that both of them has to be true. Disjunction, my or, means that just one of them has to be true. So what about this 1, 2, third one? That's false, and that is also false. False or false? Well, if they're both false, the disjunction is still false. For this one, that's false, that's true. Disjunction, or means at least one. Well, I've got one, so that disjunction there is true. Okay. So that is a quick review of what that looks like. Now it says to make a truth table for each statement. We've only got one statement. When we have one statement, we only have two cases. So we've got P, we've got not P, we've got case 1 and case 2 for P and not P. And what we're asked to evaluate is P and not P. That's the column we're really interested in. The setup is the same over here where I have P, I have not P, I have two cases. But this time we're interested in P or not P, that truth value. Okay, for my first truth table, if I only have one case, that means I'm negating that one statement. If the statement is true, the negation is false. If the statement is false, the negation is true. That is the same. These first two columns are the same over here. Now I need to evaluate the compound, P and not P. Well, it's an and is a conjunction. It means they both have to be true for the conjunction to be true. Neither one of those is a true compound. What about the compound disjunction, the or? Well, for the or to be true, only one, at least one, has to be true. So both of those are true. Okay, two cases when I only have one statement. What if I have two statements? When I have two statements, I need 4 cases. So I have set this up to be 4 cases. Now I want you to always start with our basics. We need to know, our goal is to know P and not Q. That's our goal for this truth table. We need to figure out the truth values of P and not Q. To get there, though, I've got 1, 2, 3, 4 cases for those two statements. To get there, I need to start with my two columns P, Q, but then I need to know not Q. So I'm going to start with my two basic columns, P and Q, and then from Q, I'm going to figure out not Q so that I can look at that combination. Let's just fill in our columns and then we'll talk about what comes next. Two statements means 4 cases. We know what those look like. My P column counts 2 by 2. True, true, false, false. My Q column alternates. True, false, true, false. Now to get not Q, I have to look at Q because my not Q is just negating Q. That means the truth value switches. So if Q is true, false, true, false, not Q is false, true, false, true. All right. Now, here is your tip. You are never going to be looking at more than 2 columns. To get not Q, we just looked at one column. We just looked at Q. To get P and not Q, I need to look at P, and I need to compare it to not Q. So I don't need to look at that Q column. I'm only looking at these 2 columns. Now, this is a conjunction. It's an and. For my and to be true, both statements have to be true. So I'm looking to see in which case both statements are true. Well, they're both true in case 2. The other 3 cases have to be false because they are not both true in those cases. So that's the column that I was looking to build. Let's go again. Let's look at not P or not Q. Now, that is my goal. My goal case is to figure out the truth values of not P or not Q. To get there, I need to be able to compare not P to not Q. You know what? Let's adjust this a little bit. Let's do this so that we can do P, Q, not P, not Q. Okay? Let's do that. Let's do P, Q, not P, not Q. 2 statements, 4 cases. P is 2 by 2. True, true, false, false. Q alternates. True, false, true, false. Okay. Now we need to figure out not P. So to figure out not P, I look at P. P is true, true, false, false. So not P will be false, false, true, true. Okay, now I need to get not Q. To get not Q, I need to look at Q. Negation changes the truth value. Where Q is true, false, not Q is the opposite. False, true, true. All right, then I'm at the end. I need to figure out the truth value of the compound. I have a disjunction, an or. I'm comparing not P to not Q, so I don't need those first 2 columns. I just need the next 2, not P compared to not Q. Truth values for the or, the disjunction. For the or to be true, at least one of them has to be true. So this first case, that's false because they're both false. But the rest of these have at least one true, so the compound or, the disjunction, is true. Let's introduce some vocabulary. Tautology and self-contradiction. First of all, a tautology. A tautology is a compound statement that is always true. A compound statement that is always true is a tautology. And you can help remember that because it starts with a T. Tautology, always true. Self-contradiction is kind of like it sounds like. It's going to be a compound statement that is always false. It contradicts. It is never true. So hopefully you can remember tautology starts with T. It's always true. Self-contradiction is the other one. It's always false. So on the statements, that the compounds that we have done 4 truth tables in this video. Out of those, which of those compounds were a tautology? Well, if you look at that last page that we did, tautology right here, P and not P, that is a tautology. P and not P is a tautology. Were any of these statements self-contradictions? Well, I said and, that's an or. Sorry guys, P or not P. That's a disjunction. P or not P is a tautology. P and not P is a self-contradiction. P and not P is the self-contradiction. P or not P is a tautology because that last column is true all the way down. P and not P is a self-contradiction because that last column was false all the way down. What about these 2 truth tables? Are either one of them a tautology or a self-contradiction? No, because when I look at that final column, I've got 3 F's, 1 T. Over here, I've got 1 F, 3 T's. It's all or nothing for tautology and self-contradiction. We don't have all of either trues or falses in that final column. All right, we have some truth tables to fill out. We're going to start with PQ. Now, my general rule for written truth tables is that if it's on that page, you can use it. You don't have to redo it. So, for example, once I get P and Q down in this first one, I don't have to recopy P and Q. You can always add more columns if you like that organization and you like to see all of them right there. For this truth table, I've got 2 statements, so I've got 1, 2, 3, 4 cases. That's correct. I have P, I have Q. Now, I have to work from the inside out. My goal, my last column, is always going to be what I'm given to figure out. So in this case, what I'm given to figure out is that negation. What do I have to know to get the negation? Well, let's kind of work backwards. To get that negation, I have to know what's inside parentheses. Inside parentheses is P or Q. To get P or Q, I have to know P as well as Q. You see how I set that up? I started with my goal, the negation. To get the negation, I have to know the truth values of the inside parentheses part. Inside parentheses is P or Q, and to know P or Q, I have to know P as well as Q. Let's set up our columns. P is true, true, false, false. Q is alternating, true, false, true, false. To get P or Q, I compare these two together. Or is a disjunction. It's an inclusive or. If one is true at least, then this truth value for the or is true. So I've got true, true, true. This last case is false. Case 4 is false because false, false. Neither one of those is true. All right. To get my final column, that negation, I don't need to look at the P or the Q column again. All I need to look at is the P or Q column, and then I need to negate it. Negate it means I switch the truth value. So that's my goal, this column. This column, this truth table is not a tautology, and it is not a self-contradiction because I have 1 true and 3 cases that are false. All right, let's look at this next one. Remember, I said that you can back up and you can add in everything if you want, but we're going to kind of think about this from the goal working backwards. Well, my goal is to get the negation of what's in parentheses. That's my goal. The negation of P or not Q. Well, to get that, I need to know what's inside parentheses. What's inside parentheses is P or not Q. To get P or not Q, I need to know P. I need to compare it to not Q. So that's what I build here. I could have split this column and done P, Q, and then not Q, and then compared the P to not Q, and then I'm going to look at this column. Totally up to you. This is what I'm going to go with. So my P column is true, true, false, false. That's always what it is. Not Q. Well, I've got Q right here above it. Q is true, false, true, false. So not Q will be false, true, false, true. You see what I mean about having it on the same page? It's easy to refer to. Okay, the next one, P or not Q. I have to compare both of these. Or means if it is true in at least one statement, it's true for the disjunction. So this time my third case is false. Notice that P or not Q is this different truth value set than P or Q. All right, and then to get to get the negation of P or not Q, I'm just negating that final column that we created, P or not Q. Negation means I change the truth values. Again, not a tautology, not a self-contradiction, also not the same as the column, the truth table above it. They're very similar in the way I set them up. This is the negation of P or Q. This is the negation of P or not Q. Do not give me the same set of truth values. They both have 3 falses and 1 true, but they're not in the same order, so that is not the same truth table. Let's do this next one. Now we have the negation of not P or not Q. You see we're kind of adding 1 not to each successive statement. So our goal is not P or not Q. That's our goal, what we're given to figure out. I'm going to start with that. I'm going to work backwards. Well, to get this, I have to know not P or not Q. To get not P or not Q, I have to compare not P to not Q. All right, not P. Well, if this one is P, then not P is the negation of that. And we know not Q. This is not Q right there. Then we have the disjunction of those two. If at least one of the 2 statements is true, our disjunction is true. So that first case is false, and the other 3 are true. And finally, our goal is to negate that column. So we're just looking at that column. We're not looking at the first 2 columns, just this one, and we're negating it. So it becomes true, false, false, false. One more time. Not the same as the other two truth tables, because even though each of them has one true and three falses, they're in different orders. None of them are tautologies. None of them are self-contradictions. All right, the idea of logically equivalent statements. Logically equivalent statements are two compound statements that have exactly the same truth values. If they're logically equivalent, they are compound statements with exactly the same truth values. That means the same order. So none of those truth tables that we just created were logically equivalent, which means that the answer to number 6 from the previous pages, are these two truth values, truth tables, logically equivalent? We can go look back at them, but no, they aren't, because even though they had the same number of truths and falses, those truth values were not in the same order, and order matters. Okay, here we go again. Our truth table got bigger. Why did it get bigger? Well, it got bigger because we have 3 statements, P, Q, R. And when we have 3 statements, that means we've got 8 cases. 3 statements means 8 cases. It's really not any harder. It's just longer. So we've got case 1, 2, 3, 4, 5, 6, 7, 8 cases. Our goal, the thing that we are getting to at the end, is all of this. P or, not Q and R. That's our goal. This is the column we're working towards. And this column represents a disjunction. It's a disjunction between P with what's in parentheses there. So we need that set in parentheses. So this next column over is going to be not Q and R. Well, to get not Q and R, we're going to have to know not Q. Obviously, we're going to have to know R. I've got 4 columns left, so I could do P, Q, R in order, P, Q, R. And then I also need to know that not Q, because it's not on this page, right? Okay, so we haven't done an 8-case truth table yet. We just double everything. That's all we do. We just double everything. So for a 2-statement truth table with 4 cases, P went down 2 by 2. True, true, false, false. I double that. Instead of 2 by 2, it goes 4 and then 4. So I say 1, 2, 3, 4 trues, and then 1, 2, 3, 4 falses. That's my P column. Q also doubles. It was just alternating true, false, true, false. Now it's going to go 2 by 2. So it will be true, true, false, false, true, true, false, false. Then we get to our 3rd statement, R, and it alternates. True, false, all the way down. Okay, next we need to figure out not Q. Well, to do not Q, I just have to look back and negate that Q column. That's the only column I need to look at. So I'm going to cover up my other columns so they don't distract me. And I'm going to negate the Q column. Well, the Q column goes 2 by 2 starting with true. So not Q will go 2 by 2 starting with false. That's the negation of Q. Okay, my next column wants me to look at not Q and R. Not Q and R. Well, so I need those 2 columns. I need not Q, I need R. This is a conjunction. It's an and. For my and to be true, they both have to be true. So let's look through here and see if you can find the cases where both statements are true. Well, case 3, they're both true. In case 7, they are both true. The other cases all have to be false. All All right, we're down to that last column, that disjunction that we're interested in. To find the disjunction, we are just looking at, remember you're only ever looking at 2 columns. To find the disjunction, you're going to be comparing P, all the way back there at the beginning, to to that not Q and R. So I'm looking at my first column, P, and this last column I filled in, not Q and R. It's a disjunction. Disjunction is or. So if I have at least one true statement, one or the other is true, or both, it's true. Which means if they're both false, it's false. Let's look for the cases where they're both false. That might be a little easier because I see lots of trues. Down here, case 5, they're both false. Case 6, they're both false. And case 8, they're both false. But the others have 1 or 2 true statements, so they are going to be true. Okay, another 8-case truth table because we have 3 statements PQR. We're going to start by filling in our goal down here at the end. Now, when I talked about my math lab doing things differently, basically they just arrange it differently. They might put this in the middle somewhere instead of at the end. You're working through it the same way, even if it's in a different order. Okay, to get this, I see that I'm going to need P, not Q, R. I see that I'm going to need what's inside those parentheses. So let's write that down. What's inside those parentheses is P or not Q. So that's going to be this column, P or not Q. That got blurry. P or not Q. That's what's inside parentheses there for this column. And then I've got 4 columns available here. Let's do my P, Q, R, and then I need not Q to get that's going on inside there. Which means that the first 4 columns look identical to that last truth table that we filled in. Don't look though. Try to fill it out without looking back. I'm going to fill mine in and then we'll get back together. Okay, I've got my first 4 columns filled in. To get P and not Q, I just look at those 2 columns. I don't look at the others. I'm just comparing P. I'm just looking at the truth values of P with not Q. This is an or. It's a disjunction. So if one of them is true, then the disjunction is true. So I'm looking down to see they're both false here. They're both false there. Just in those 2 cases. The other 6 cases are going to be true. Just case 5 and 6 are false for P or not Q. Then to get my final column, that is my goal that I'm really interested in, I'm interested in this last column that represents what's in parentheses right there. And I'm also interested in the R column. So I'm only looking at those columns. Only looking at those columns right there. Those are the only 2. Remember, I said you're never going to be looking at more than 2 at a time. Well, this is a conjunction. It's an and. To be true, both of them have to be true. So case 1 is true. Case 3 is true. Case 7 is true. But all the other cases are false. Okay. Our last question on this page asks, if these 2 truth tables on this page are logically equivalent. Well, hopefully the quick answer is no, they're not. They do not have the same truth values in the same order. Okay, so for number 9 on the next page, we have 3 different truth tables. They're a little smaller. There's only 4 cases because there's only 2 statements in each. It says to determine whether each statement is a conjunction, disjunction, or negation, and then make the truth table. Well, these first 2 are both negations because that's all that's going on outside the parentheses. This third one is a conjunction because remember, we only name it a negation if that is all that's going on outside the parentheses. That's the only time we do that. We need to set up what our truth tables are going to look like. I know for this first one, I have not P and Q. That's the goal that I'm after. For this one, the goal is not P and not Q. And for this one, my goal is not P and not Q. So how am I going to get there? Well, for the first truth table, to get this, I need to know what's inside parentheses. That would be P and Q. And to get P and Q, I have to know P, I have to know Q. For the next truth table, I need to know what's inside parentheses, that P and not Q. To get P and not Q, I have to know P, I have to know not Q. I'm not going to have to rewrite Q because I can look over here and get it. Down here, I don't have any parentheses. So really, all I have to put as part of this truth table, all I'm requiring you to put, would be not P, not Q. If you want, you can split this and make it PQ so that you have all of those columns in the same truth table. That's fine. But you have to, at minimum, have these things that I have written down. You can always add more columns in for each truth table. Don't do less. I'm going to fill in these truth tables and then come back on the video with it filled in. I want you to stop the video, fill yours in, and then we'll have a quick discussion about them. Okay, here we go. Compare your truth tables to mine. Start with the columns in blue, the P, the Q, the not P, the not Q. Remember, P and Q are standard. Not Q negates the Q column, changes the truth value. Not P negates the P column, changes the truth value. Then I do anything inside parentheses. So for my first truth table, I have P and Q, and is a conjunction. It's only true if both statements are true. For the second truth table, I have P and not Q, so I'm looking at these two. Again, it's a conjunction. It's only true where both statements are true. I don't have a parentheses on this third truth table, so let's go look at our red columns. For the first truth table, I'm negating this column that's right in front of it, so I'm only looking at that one column to get my goal. Same case for the second truth table. I'm only looking at the column just in front of it because I need to negate that column. For this final truth table, I'm doing a conjunction of those two columns. So I need to see where they are both true, and that happens in case 4. Are any of these three truth tables logically equivalent? Well, no. They don't. None of them have the same truth values in the same order. Are any of them tautologies? All true? No. Are any of them self-contradictions? All false? No. And when I say tautology, I'm only interested in that last column, that goal column that we filled in. Okay, number 10 at the bottom of the page says to find the compound statements from numbers 2 through 9 that are logically equivalent. And now I'm going to tell you that there are 2 pairs of compound statements that we have done in this packet that are logically equivalent. So I want you to pause the video. I want you to look back over the truth tables that you have constructed to this point, and I want you to find the statements that are logically equivalent that have the same truth values. When you find those, you should discover that the truth table for the truth values for not P and not Q is logically equivalent to not P and Q. So not P or not Q is logically equivalent to not the negation of P and Q. Also, not P and not Q is logically equivalent to not the negation of P or Q. Now stop for a second and look at the arrangement of those terms. Truth tables don't follow the same rules as arithmetic, but if you think about what we call distribution or distributive property in arithmetic, we've got this negation outside these parentheses. If I distribute it inside in arithmetic, it just makes both of these negative, right? Well, this is not arithmetic. This is not just a negative. But notice that if I think about, distributing it inside so that this becomes not P, this becomes not Q, what happens to my symbol? Well, my symbol flips. So not, the negation of P and Q, is equivalent to not P or not Q. Likewise, the negation of P or Q is logically equivalent to not P and not Q. So I can think about kind of distributing, but it's not the distributive property because this is an arithmetic. But I can think about distributing that negation inside my parentheses. When I do that, that compound symbol switches. My conjunction becomes a disjunction, or vice versa. All right, we have a few more truth tables to practice on. Number 11 says to determine whether each statement is a conjunction, disjunction, or negation, and then we're going to make the truth table. Notice that both of these truth tables have 8 cases because they both have 3 statements. What type is this? What type of compound? Well, my and is on the outside. This is a conjunction. This one, my or, is on the outside, so this is a disjunction. And we're going to determine if these truth tables, if these 2 compound statements are logically equivalent by looking at and comparing those final columns for each of them. Okay, our final column, remember, is our goal because that's the way we set this up and structure it. In my math lab, we're prepared that it may organize it a bit differently, but this is how we are doing it. So our goal statement here is not P and then in parentheses Q or R. And then the second one, our goal is parentheses, not P and Q, and then or R. So we have not PQR, not PQR. We have our conjunction, disjunction in the same order. We just move the parentheses. So basically our question is, does moving the parentheses matter? Does it change the truth value, or do we get 2 tables that are logically equivalent? We're going to set up what the headings of the columns look like for our 8 cases in each table. And then I'm going to pause the video, fill mine in, and I want you to do the same. Okay, working backwards, I need this parentheses. So this one is going to be Q or R. And then I need to compare that to not P. To make that happen, I'm going to need to know P, Q, R because I don't have any of those on this page. All right, down here, I need the parentheses here would be not P and Q. I'm going to need to compare that to R. I need not P and Q. I don't have to do P here. I could do P as well as not P and Q. It's totally up to me. But I need the ones I'm going to look at. And I'm going to look at not P, Q, R, as well as that conjunction. So I need these in this truth table. I don't need this P column, but I can put it there. Okay, pause your video, fill it in, and then compare. Okay, I filled in all but the last column for mine. You can see P, Q, R, not P are standard columns. When I get to the compound that was in parentheses, for this first table, I have Q or R, which means I only need to look at these 2 columns, the Q column with the R column. It's an or, so as long as one of these are true, the or statement is true. So it's going to be false here in this 4th case, and it's going to be false here in the 8th case. To finish this one off, I'm going to compare not P to that compound Q or R. So those last 2 columns are the only 2 I have to look at to find this final answer column. Now it's an and, it's a conjunction, so it's only true where both of these are true. That happens here and here, and here, 3 cases where they're both true. The other cases are false. Okay, let's look at the second truth table. To get what was in parentheses, this conjunction between not P and Q, I just look at those 2 columns, the not P with the Q column. It's a conjunction. I'm interested in where they're both true. So I look through here and I see they're both true in these two cases, 5 and 6, and they're false in all the others. To get this final column, I need that conjunction column compared to R. So I've arranged it where these are my last columns right here again. This one's a disjunction, it's an or. So as long as it's true in one or the other, it gets to be true in this disjunction column. You know what? I don't have a true statement for case 2. I don't have a true statement for case 4. And I don't have a true statement for case 8. But the others have at least one true statement. So that's what that disjunction column looks like. Okay, the question at the bottom of the page asks, are these two truth tables logically equivalent? Does it matter if I move the parentheses? Well, they are not logically equivalent. I do not have the same truth values in the same order. So it absolutely does matter where I put the parentheses. All right, last page for this set of notes. Determine whether each statement is a conjunction, disjunction, or negation. Make the truth table. And then we're going to label each one as a tautology, a self-contradiction, or neither. Okay, so what is this one? Well, it's a disjunction because that's what's going on outside. And this one is a conjunction because that's what's going on outside my parentheses. This last column needs to be really long. I'm not going to be able to write that in there very well. So I'm going to cheat. I'm going to say, you know what? That's this goal right there. That's this goal right there. I only have 2 statements, so I only have 4 cases for each of these. For this one, I'm going to need to know, both of these sets of parentheses. So I need to know not P or not Q. I need to know P and Q. To get there, I'm going to need to know both P and Q and their negations. So for these first 4 columns, they're going to be P, Q, not P, not Q. For the second truth table, we're going to go ahead and set it up. To get this goal statement here, I need to know these 2 sets in parentheses. And we can't use what's above because notice this one is not P or not Q. This one is not P and not Q. This one is P or Q. And since I have all 4 of those statements above, I don't need to rewrite those. I can just fill in these 2 columns looking above. If it helps me though, if it helps you, you can go ahead and recopy these 4 columns for the second truth table. I'm going to pause the video, fill these in, and then let you compare. Let's focus on this top truth table, the disjunction between those 2 compounds. We filled in P, Q, not P, not Q. And then to do P and Q, we looked at those first 2 columns, P, Q. Where they are both true, we have our true case, that first case, the other 3 are false. To fill in not P or not Q, I looked at the not P, not Q columns. It was false in the first one because they're both false. It's true in the other 3. And then to get my final column, that final result column, I'm comparing these 2 that have in what's going on in parentheses with a disjunction, with an or statement. So if one of them is, at least one of them is true, the or statement is true. And I can see that I have a true statement in each of those cases, which means that this is a tautology because all of my cases in that final column are true. Okay, let's look at this final one. To get the final truth table in this packet, I did P or Q. So I looked above at the P or Q columns, P column with the Q column, and I got true, 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 false. Then to get this one, not P and not Q, I was looking at not P. I was looking at not Q above and seeing where they were both true. They're only both true in that 4th case. Then I have a conjunction. The conjunction is only true if both of the statements are true, and I don't have any case where both of the statements are true. So this is a self-contradiction because all cases are false. And that's my answer to number 14, where I have labeled the first truth table as a tautology and that second truth table as a self-contradiction.